So in order to make progress with these laws of probability, we're going to introduce a new concept in this lesson called conditional probability. It's a very basic concept when we're looking at these laws. So I'll explain it by way of an example, and we'll pick an easy example. We'll look at a roll of a fair die. So we've seen this many times before. So at this stage we know that the sample space, just all the possible outcomes, we can list those very quickly. So 1, 2, 3, 4, 5, or 6, those are the possible outcomes. So let's pick out a pair of events, and we'll look at conditional probability with respect to these events. So our first event, and I'll use red for this, is that we roll at least a 4. Okay, so we can pick that out in the sample space. I'll circle those outcomes in red. 4, 5, or 6. So that's the red event there. And we'll pick another event in green that we roll an even number. And again, it's easy to pick out those events. So 2, 4, or 6, those are the even ones. Right, so we have two events there. So what do I mean by conditional probability? Well, let's calculate the probabilities of these events for a start. So the probability of A, the probability that we get at least 4, it's easy to calculate. We have 3 outcomes. So all the outcomes in this sample space are equally likely. So we have 3 successful outcomes and 6 total. So we get 3 over 6, which is a half. And the probability of an even number, so the probability of B, again, how many successful outcomes do we have? We have 1, 2, 3. Those are the green ones, and a total of 6, so 3 over 6 again, which is a half. So each of these events has probability a half. So now, what's conditional probability? Well, let's say that we ask for the probability of an even number given that we roll at least 4. So this is the probability of B, which is an even number, given that A occurs. So what's that probability? Well, effectively, what's happened there is that we're just restricting to a particular subset of the sample space. We're forgetting about 1, 2, and 3, those outcomes. We're just saying that it's given that A occurs, so that means we're given that 4, 5, or 6 has been rolled, and we're asking for the probability of an even number given that that's true. So again, we can just calculate with a simple counting argument. Now we have 2 events that count as successes, right? 4 or 6, and the total number of possibilities now is 3, right? Because A is the event that at least a 4 is rolled, so we only have to consider 4, 5, or 6. So we get 2 over 3. So this is a typical example of a conditional probability. So this is a conditional probability. We're asking for the probability of an event conditional on the assumption that another event occurs. So in this case, we're asking for the probability of B given that A occurs. Now there's a shorthand notation for that that's very commonly used. So this, instead of writing down B given that A occurs, we just write it like this: probability of B, and then we put a vertical line and A. So that means B given A. So that vertical line there is just a shorthand for given. Okay, so let's look at another example where we can calculate this conditional probability. Okay, so in this example, we're given some data about the heights of a group of girls and boys. And we're given the data in the form of a back-to-back stem and leaf plot. So if you are not sure about stem and leaf plots and you're not sure how to read them, just make sure you go and review that lesson on stem and leaf plots. And so we're given this data and we're asked to calculate the probabilities of various different events. And each of these events concerns a randomly chosen person from this population. So we pick some person at random and we ask some question about that, and we want to know the probability of getting certain answers. So we've listed 3 events here. B is the event that the random person is a boy, G is the event that the randomly chosen person is a girl, and T is the event that the randomly chosen person is at least 170 centimeters tall. And now we have 5 different probabilities to calculate. So in this case, there are how many outcomes? Well, the possible outcomes correspond to the number of people in the sample. So we can just count them up, and you can see straight away that there are 20 data points there. So there are 20 possible outcomes in our sample space, and each of them is equally likely. And so to calculate probabilities, we just calculate the total number of outcomes in each event and divide by 20. So let's look at the first one here, P of t. So what's the probability of t? Well, it's going to be the number of people who have height at least 170 centimeters. So we can read that off easily from the stem and leaf plot. We just have to count the data points in the rows corresponding to 17 and 18. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And the total number, remember, is 20. So we've 9 over 20. So that's A there. So that was easy. So what about B here, right? Well, this asks for the probability that the person is at least 170 given that they're a boy. So now we're just looking at the boys now. We can forget about the girls in this calculation. And so we calculate the number that have height at least 170. So we count them up 1, 2, 3, 4, 5, 6, 7. So P of t given boy is 7, and now we divide by the total number of boys only, because it's given that we're dealing with a boy here, so we can forget about the girls for the moment. And the total number of boys in this population is 10. So 7 over 10. So you see that these two probabilities are different. The probability of t without any condition is 9 over 20, which is the same as 0.45. And the probability of t given b is 0.7. So they're very different. And that's to be expected, right? If you restrict yourself just to the boys, the probability that person is going to be above a certain height should be different than if you look at the whole population. So let's continue. We want to calculate the probability of t given g. So that's part C there. The probability of t given g. So now we have to, so let me draw a line here just to separate the data off. We want to calculate the probability that the person is above 170 given that they're a girl. So now we're just looking at these two outcomes here, the 8 and the 5 in this row, and dividing by the total number of girls. So the probability of t given g is 2, that's the number of successful outcomes here, divided by the total number of girls, which is 10, and that's 0.2. What about D? So here we're turning it around a bit. We're asking for the probability of B given T. That's the probability that the randomly chosen person is a boy, given that they're more than 170 tall. So now we're restricting ourselves to just a bit above this line that I've just drawn here, and we want to know in that subset of the sample space how many are boys. Okay, so the probability of B given T. So now we look at the bit above the line here, and how many of those are boys? Well, 1, 2, 3, 4, 5, 6, 7. And how many in total are above the line? Well, you can count them and you see that there's 9 data points above the line, so 7 over 9. Okay, so something to note here is note that the probability of t given b is different from the probability of b given t, right? And that's true in general. They're not the same. So the order here in these conditional probabilities is very important. And finally, we'll work out the probability of b. Well, that's easy. Probability of B, well, that's the number of boys over the total number of people. So it's 10 over 20. You just count them up there. You see there's 10 boys and there's a total of 20 people. So that's 0.5. So that tells us if we randomly choose a person, there's a 0.5 chance that it's going to be a boy. But look at the previous calculation, D there. If we know that the person is more than 170 tall and we randomly choose a person, then the probability is 7 over 9, and that's 0.77 repeating, right? So these are different. So you see that being told that the person is at least 170 tall changes the probability that they're a boy. So that's one way to interpret conditional probabilities. It's a conditional probability says, okay, I have some extra information, so now what's the probability of my event occurring? Okay, so there are some simple calculations of conditional probabilities.